Welcome to my mathematics lesson video. Today we are going to look at a very interesting grade 9 topic, which of course it has given a lot of people challenges just to identify which one is which one is that. So today we are going to make it simple and simpler for you to be able to get a distinction in grade 9 mathematics, especially paper 1 multiple choice. So now today we are looking at real numbers. Real numbers is a grade 9 topic. Of course, lesson number 1. Now, we need to understand what a real number is. And in these real numbers, we are going to focus more on two different kind of numbers. And these two different kind of numbers are the ones that we are going to look at very closely because they are the ones that mostly are examined. Now, what is a real number? Real numbers are the numbers which include both rational and irrational numbers. Real numbers are numbers that include both rational and irrational numbers. So you need to know what a rational number is, and you need to know what irrational number is. And you need to be able to differentiate between these two. Then it means that you know what real numbers are. So let us begin with the rational numbers. Rational numbers. What are rational numbers? We are simply saying a rational number is a number that can be written in the form of A over B. It's a fraction, this one. Where A and B are integers. Are what? Integers. Now, what are integers? In other words, integers, these are positive and negative numbers, including 0. Those are integers. And B is not equal to 0. Now here they have specifically telling us that these integers, they include 0. But in this scenario, 0 should be excluded, but the rest of the numbers should be included. Meaning the positive and the negative numbers should be included except 0. So the B, meaning the denominator, should not be equal to 0. If it is equal to 0, my dear friends, it means that that is not a rational number. That is not a rational number. That's what they are saying. So now, let us look at examples of rational numbers. Rational numbers include the following. Number 1, we have fractions, decimals, terminating decimals. I even gave an example. Terminating decimals, terminating simply means the decimals that end. For example, 0.2, or we can say 0.5. Those are terminating decimals. We have repeating decimals. Repeating decimals, we have examples as 0.66666666666 going like that. Those are repeating decimals. Or sometimes you may have a scenario where we have 0.4545454545. That is a repeating decimal. 45 is repeating itself. So that is an example of a rational number. And also negative numbers. Negative numbers. These are positive or negative numbers which are integers. That is what a rational number is. Note that every integer number is divisible by 1. That is every integer number, be it -1, -5, is divisible by 1. That is a fraction with denominator of 1. So every number that you are going to write, every number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 100, whatever number is, that is a rational number. Because why is it a rational number? It is divisible by 1. 2 is divisible by 1. 3 is divisible by 1. 4 is divisible by 5. -2 is divisible by 1. -8 by 1. Also -4 by 1. Also -100. It is a rational number because it is divisible by 1. That is what we mean by the definition of rational numbers. Now, another thing you should keep in mind is that square roots of perfect squares, and cube roots of perfect cubes are rational numbers. Example of these square roots we are talking about, cube roots, we are talking of cube root of 8. Because 8, we know that there is a number that can be multiplied 3 times to get 8. So this is a rational number. Also 27 is a perfect cube root. So it means that this one It is a rational number. Also this one, 8 and 27, all these are perfect cubes. Also 1 and this one is perfect cube. Also I can include and say square root of 4. This is a what? A rational number. Let's move on to another one, which is the, let's say, square root of 64. It is also a rational number. Also, we can move on and say square root of what are the two numbers when we multiply them of, let's say, square root of 25. It is, you can continue going. Square root of 4, 64, these are perfect squares. Hence now, these are rational numbers. That is what we mean by rational numbers, dear ones. Now let us come to what we call irrational numbers. What are irrational numbers? Now, an irrational number is a real number that cannot be written as a simple fraction. These numbers cannot be written in a fraction form. Cannot be written in a fraction form. That's how we know that this is the irrational number. Now, irrational numbers have infinite. Infinite means they don't end. Numbers of non-repeating decimals. Now, I hope you understand by what we mean by non-repeating decimals, because here we said that repeating decimals like 6666 or 4545, those are repeating decimals. But here they are simply saying that an irrational number, these are numbers that have infinity of non-repeating decimals, meaning that you can have 6, 5, 8, 10, 20, 30, 40, 50, 70. They are not repeating, they are different. They are different. They can continue going infinite, they don't end. That is what they mean by irrational number. Now, examples of irrational numbers here, we can look at some of the examples of irrational numbers. We have square root of 2. Square root of 2. If you are to use your calculator and find the square root of 2, you are going to discover that you have 1, 4, 1, 4, 2, 1, 3, 5, 6, 2. They are not repeating. They are not the same. We don't have a scenario where we have 6, 6, 6, 6, 6. No. Here we have 1, 4, 2 is another number. 1, 3, they are just individual. They are not repeating. They are not the same in other ways. Same applies square root of 3, square root of 7, square root of this, cube root of 4, cube root of 11, etc. Therefore, now we know that all these are irrational numbers. An irrational number cannot be written in a fraction form as A over B. No, it cannot. Also, we are simply saying an irrational number has non-repeating decimals. So, non-repeating decimals are irrational numbers. For example, pi. Pi is a special and unique way of a unique irrational number. Because why? It can be written in a fraction 22/7. But remember, we said that the decimals are not repeating. They are not the same. We have 3, 1, 4, 2, 8, 5. So you see that tells you that this is a rational number. Square root of 7. We have 2, 6, 4, 5. They are not the same with these ones. There is no number which is repeating here. 6, 4, 5, 7. They are different. 1.7, all these they are different. You see, this is the decimal point. All these are different. So meaning that these are irrational numbers. That is another way you can say of irrational number. Okay. Hopefully I've made these two rational and irrational number to be understood. Remember, terminating decimals are rational numbers. Repeating decimals are rational numbers. Non-repeating decimals are irrational numbers. And if numbers that cannot be written in a fraction form are irrational number, like square root of 2, square root of 3, cube root of 4, cube root of 11, cube root of 9, cube root of any number that you know that doesn't have a perfect square or perfect cube. Simple. Exercise. Work out this exercise and give me your correct answer. This is a 2022 paper. It's a 2022 paper question, and this is a 2016 paper 1. 2022 and 2016 paper 1 question. This is how they ask questions of this in multiple choice section A. 10 marks, of course, it falls under 10 marks. So if you are able to answer this, then it means that this topic is finished, it's done now. You concentrate on Pythagoras theorem, the next topic. Now finish that one. Let's see how you can answer that. Okay, hopefully you have answered. Now let's see the correct answer. Which of the following is a rational number? Which one of these is a rational number? A, square root of 10, B, square root of 9, C, square root of 8, D, square root of 6. Which one is a rational number? Remember, we said that perfect cubes and perfect squares are rational numbers. So look at this one. Is there any number we can multiply 2 times and we get 10? No, there is no number. 5 times 5 is 25. 5 times 2 is 10. Of course, they are not the same. They should be the same for us to get 10. So automatically this one goes out. Is there any number, this single number, when you multiply by itself, we get 9 2 times? Absolutely no. 3 times 3 is not, okay? Let's say 3 times 3. What is 3 times 3? Hey. 3 times 3, it is 9. Aha, good. Okay. So meaning that automatically here, I know square root of 9. 3 times 3 is 9. So it means that a perfect square, it is a rational number. So this one now becomes my correct answer. Even put a cross like that. This is my correct answer. There's no number. 2 times 2, 4 times 4, it cannot be 8. There's no number I can get 6 there. So this one is my perfect answer. I put a cross there. Okay, then I move on to the next one. Which of the following is an irrational number? Okay, let's start from D. D, 2 over 5. This is a terminating decimal. Remember, we said terminating decimals are a rational number. 5 into this is 0.4. 0.4. It's a terminating decimal. So this is irrational. Rational number. 1.01. This is also rational number. So it cannot be rational. We have square root of 4. 2 times 2 is 4. So it means that this is a rational number. Pi. Remember, I didn't even erase. Pi is it has 3.142. It has non-repeating decimals. Hence, this is our answer. So we put a cross, or we can circle this as this is our answer. And you are done. Hopefully this video has helped you in one way or the other, and you will never fail, because you have become now an overcomer of mathematics. Just like I am an overcomer, you are also an overcomer. Watch this video constantly and make sure you write the notes in your notebook so that you can have a hard copy to give a reference whenever you want to check on 1 or 2 things. Remember, mathematics is a practical subject. There is no medicine for you to be good in maths. You just have to practice daily. Every day solve a question, 1 or 2 questions, for you to make your mathematics skill better and better and better. As for now, we end here. Hopefully I've made these irrational numbers easy for you. Next video we shall look at interesting topic, which is Pythagoras theorem. Pythagoras theorem is also an interesting topic. Don't miss, because you are going to enjoy. So make sure that you subscribe and like and comment, so that each time I post a new video, you get to be notified and you get to instantly watch it and get to the knowledge that you deserve. God bless you, and see you in the next video. Bye-bye.